Hello everyone. So welcome to series of videos on logistic regression. In the last video, we saw with data that if we follow this formula for to derive to calculate the loss and cost, the the shape of the cost function would be convex. Another thing I just wanted to highlight that why this another series of videos of logistic regression. There are many videos available. I'm trying to just fill a gap where where I found that okay, had those videos or has those material could have explained these things, probably it could have been better for me to understand. For an example, I saw many documents, I saw many videos which says that okay, if we follow this cost function, if we follow this formula to calculate the cost function, the shape of the cost function would be convex. So what I did additionally to have a good visualization, that I tried this. Okay, let me just put let me see how does it make a convex shape. So let us proceed from there, and I will in this video I will try to visually explain what is gradient descent. I will not go to the mathematical explanation. So let us do. So I have this data set, and again for each of visualization I'm going to have a single dimension as a predictor. So I have only x. I'm not going to use the bias term. So in my data set I have one independent variable and one dependent variable. X is the independent variable and y is the dependent variable. So this is a data set which I have got from which site I don't remember. So this is a data set for logistic regression. So I create a data set. Okay, I create a data frame. Now to understand that what would be the value of the parameter for the logistic, I have created the logistic function. So I'm not going to run this because I know the minimum value for at the value of b where the cost function will have a minimum value is 7.56. So I know that. So what I will do, as I explained in the last video, uh, that I will draw a cost function. So this is the cost function I drew. And how I did that, I know that minimum value is 7.56 somewhere here. Yeah, 7.56. So what I did that I went some step this side and then some step this side, and at each point I calculated that if my b had been, let us say, 5.35354, what would have been the cost. Similarly, I added all this at the interval of 0.001, and so I got a data frame such like that if b is 5.382, the cost is something like that. If b is something 5.671, cost is something like that. So once I got those two values, I could draw I could plot between the parameter b and the cost, and it gave me a cost function, shape of the cost function something like this, which is a convex. So that's how I could visualize that if I use this formula to calculate the cost function, the shape of the cost function would be convex. So I could see this now. So that's what I wanted to contribute to the group. Okay, now let us proceed for the gradient descent. In reality, when we try to find the best parameter for the data set we have for the logistic regression, in reality we do not know this curve, but we know that shape will be convex. But how will it be, like this or will it be like this one, following this kind of thing, very squeezed one, that we do not know. So now what is that I want to achieve? That I want to know this point 7.56 somewhere where the cost is minimum. Gradient descent is one of the algorithm which help us in finding this. Remember this slide, what we do in logistic regression, that we initialize the value of b, which is a parameter. Here I have written theta 0 and the initialized values. We initialize anywhere, and we keep on doing these iterations till we reach to the minimum point. So we do the random initialization. So I can start here, I can start here, I can start here, anywhere. And it is assumed, or it is, I think it's proven, that anywhere we start, if we follow the gradient descent, we would be able to reach to this minimum point. That's what, so gradient descent is in a, it's an algorithm which help us to reach to the minimum point of the convex cost function given we initialize at any place. How does it work? We can say this mathematically also, but I'm not going to show this mathematically. I'm going to give a visualization of this particular gradient. How does it work? So I have built some functions. I know the minimum value is 7.56. So this is the cost function. What I'm going to do is that this is one function which will calculate gradient at different places. So I have taken the same data set. I am initializing at 10, this point. Randomly I am starting from the value of 10 of the parameter theta or b. 1 is the learning rate. I will come to that a bit later, learning rate. And this is the iteration, how many iterations I want to do. So if we do the gradient descent, it will calculate the gradient descent values. And how does it help? I want to show you here. So assume that we did the first iteration of gradient descent. Then I'm just plotting how does it work. So all the values of the gradient descent for the 15 iterations is stored in this data point. We are starting from the point 10, right? And at this point, cost is 0.3006. This is the cost. We learn with the rate of 1. The learning rate is 1. If we give the learning rate as 1, the new value of x would be 8.99 and the respective cost will be 0.29. See, the cost got decreased from 0.30 to 0.29. Now again I do further learning at this new point and I reach to this point. Like this I keep on doing. So how graphically, let me show this. Okay, so let me take the first iteration and plot it. So I have just run the plot. I'm maximizing the plot. So what happened? I started from the point 10. At this point, I don't know this curve. So which direction I should move? I should move this side or this side, up or down. The gradient at this point helps me to know that which side I have to move. So we calculate the gradient and then we move accordingly. So gradient told me to move downwards. So I moved with a dimension learning rate of 1. So this is the 1. After moving, I reached here. Here I calculate what is the cost, right? The new cost is this one. And there at this point, I calculate the gradient again. That gradients again helps me to know which direction I have to move. And then I take the second step. So now let me do the second step. Let me plot it. So after first learning, I reached here. I checked the cost, calculated the gradient, and based on the gradient, I changed my descent. See, had I followed this descent, I could have come somewhere here. But now I'm following this descent, so I'm going some other direction, right? So gradient helps me to know which direction and at what angle I need to come down or go up. And the learning rate lets me to know, that's a parameter what we give for the gradient descent, that helps me to know that how much I have to move. Okay, due to time limitation, I have to stop the video here. We'll continue from here in the next video. Thanks a lot for watching. Please follow my next video.